Hey math kids, today we're going to talk about the remainder theorem. And so if we only care about the remainder, this is a quicker way to figure it out. Okay, so if we have a problem like this and they want us to find the remainder, all we have to do is take the thing on the bottom, set it equal to 0 and solve for x, or just, in this case we know that it's going to be -2. We can, let's see, and we can plug it into the top, and that will give us the remainder. That's the remainder theorem. So once again, I just plugged in -2. So I did x plus 2 is equal to 0, subtracted 2 from both sides. I got -2, and then I plugged that in for all the x's on top. And this will tell us what the remainder is going to be. Okay, so if I do that, I'm going to get 16. Wait, I left out a 3 right there. Okay, so that piece is just going to be -8. -8 times -3 is going to be +24. And then we just have -2, -4, so that's going to be -6. If we add these together, we get 40 minus 6, which is equal to 34. So that is the remainder if we do this thing divided by this thing. Okay, the next one, we have x cubed plus 4x squared plus ax plus b. And when it's divided by x minus 2, then the remainder is 20. And when it's divided by x plus 5, the remainder is 6. And we need to find a and b. Okay, so essentially this corresponds to a +2. This corresponds to a -5. So I'm going to plug in a 2 and I should get 20. And then I plug in a -5 and I'll get 6. And that will help me find my a and my b. So 2 cubed plus 4 times 2 squared plus a times 2 plus b. And this will equal 20. So this is 8. 2 squared is 4. 4 times 4 is 16. This is 2a plus b equals 20. Add those together, we get 24 minus 24. So 2a plus b equals -4. So we'll use that in a second. Now I'm going to plug in -5. When I plug in -5, I should get a 6. Alright, so this is -125. -5 squared is 25. 25 times 4 is 100. Minus 5a plus b equals 6. Combine those, I get -25. Add 25 to both sides. And we end up with -5a plus b is equal to 31. Alright, we have two equations that we can now use to figure out what we need. So I'm just going to rewrite them. Now, if I just multiply the bottom equation by -1, that will just change the signs. Then we can just add these. So we get 7a. These will cancel. And that's equal to -35. Divide by 7, divide by 7. And so a is equal to negative 5. And then if we just use that answer in this equation, we're going to get 2 times negative 5 plus b is equal to negative 4. It's going to be negative 10 plus b is equal to negative 4. Then we add 10 to both sides. And b is equal to 6. So a is negative 5, b is 6. Alright, we have another one. Okay, so we have x squared minus 3x plus 7 . Okay, so sorry. We have some polynomial, and then it's divided by this. And then the answer, the quotient, is x squared plus x minus 1. So if I set that up a little bit more clearly, p of x over x squared minus 3x plus 7 is equal to x squared plus x minus 1. Okay, and the remainder is unknown. So plus r of x. Okay, when p of x, so the same one, when p of x is divided by x minus 2, the remainder is 29. When p of x is divided by x plus 1, then the remainder is negative 16. Find the remainder in the form ax plus b. Alright. Okay. So essentially, we can take this thing that we set up and we can take the quotient, multiply it by the divisor, and then we add the remainder after. Because technically the remainder is supposed to be over. Okay, so if we, so p of x is going to be equal to x squared minus 3x plus 7 times x squared plus x minus 1 plus the constant that goes on top of the remainder. Okay? Alright, now when we have this rx though, they wanted us to write it in a plus, what form was it again? A plus bx, I think. Ax plus b. Okay, so that's what we have. And we know if we plug in, a 2, because this is going to correspond to a 2, this will correspond to a negative 1. If we plug in a 2 to this thing up here, we're going to get 29 for the remainder. For the entire thing. Okay. So I'm kind of running out of room. But let's plug in a 2. So 2 squared minus 3 times 2 plus 7. And then we'll do 2 squared plus 2 minus 1 plus a times 2 plus b. And all of that needs to equal 29. Okay, now if we simplify this, we're going to get 4 minus 6 plus 7. We're going to get over here, we're going to get 4. I need to just erase this. I don't need this anymore. Okay, 4, and then that's just going to be plus 1. Plus 2a plus b equals 29. Okay, so this thing is negative 2 plus 7, which is 5 times 5 plus 2a plus b, 25 plus 2a plus b, and then we subtract 25, and we get 2a plus b equals 4. Alright, now we need to plug in the negative 1. We'll go up with that, so let's get rid of this. Okay, so if we plug in negative 1, and that's going to equal negative 16 when we do that. So negative 1 squared is 1. It's going to be positive 3. So that's 7, 8, 9, 10, 11. Okay, that's just a 1. 1 minus 1 goes away, so that's negative 1. And then minus a plus b equals negative 16. So that's negative 11 minus a plus b equals negative 16. If we add 11 over here, we get negative 5. Negative a plus b equals negative 5. Okay. Now, we need to take those two equations we found. So this and this, and let's write them by each other. So negative a plus b equals negative 5, and 2a plus b equals 4. I'm going to multiply the top by negative 1, so that's positive, negative, positive. Add these, we get 3a, these cancel, equals 9. Divide by 3, a equals 3. Now if we just take that and plug it into one of the originals, I'll just do this one right here. We get negative 3 plus b equals negative 5. We add 3 to both sides, and b equals negative 2. Alright, what did they want in the end? Find Rx in the form of ax plus b. So they wanted an ax plus b, so we just say 3x minus 2, and that's our answer. Alright, if you need additional help, come to Math Lab. Until then, calculate.